Welcome back to our YouTube channel, Aman Codes. In today's episode, we are going to discuss about nested or inner sets. So, in previous episodes, we have discussed predefined functions on set data type. That predefined functions are completed. Now, in today's episode, we will see nested or inner sets. Sets with the combinations of lists and sets with the combinations of tuple and sets with the combinations of sets. We will see first. So, come here, combinations. So combinations of sets with other data types. Other data types in the sense list and tuple. See here, with respect to list we are going to see. With respect to list in the sense we have here list, here list, here list only. So with respect to list, list in list. This is we already seen in inner lists or nested list. This is completed, right? Next, if come here, tuple in list. See, tuple in list we have completed in list combinations. So inside the list we have declared a tuple. So I will keep all these episodes in iCards. If you are interested, we can watch from there. This is also we have completed in previous episodes. So this set in list in the sense in list we have to declare set. This is not completed. We have to see this. So if we go to second combination with respect to tuple data type, see here tuple, tuple, tuple. So tuple in tuple. So we have completed this tuple in tuple in inner or nested tuples. So I will mention that video in iCards. If you are interested, you can watch from there. If you come here, we have list in tuple. Yes, we have completed this in list data types combinations. I will mention that video. This is also completed previously. Now, next is set in tuple. This is set in tuple we have to discuss in this combinations, the set combinations. So if we come to the third combination with respect to set, here we have set in set, list in set, tuple in set. So we have to complete these three combinations. So we have completed these four combinations in previous episode. In this set data type combinations, we have to complete five combinations. Five combinations are set in list, set in tuple, and set in set, list in set, tuple in set. These are the five combinations we have to complete in these combinations of set data type. So the topic is nested or inner sets, right? So let's start with set in set. So this is our first case. So let's take here first case set in set. Nested or inner sets in the sense a set which is defined in another set is known as nested or inner set, right? So let's see here. This is our set and these are the elements. If I have another set and these are the another elements, then it is known as set in set, right? One set which is defined in another set, right? One set which is defined in another set is known as set in set. So let's see the content of set in set. It is not possible to define one set in another set. So set in set is not going to be defined because sets are both mutable and immutable, right? And for accessing those elements, we need indexing. So it is not provided by the set concept, right? And it gives a type error. Can't use a set as a set element. So if you try to define like that set in set, then we are going to face an type error. Why in the sense? So in order to access the inner set element, the outer set must and should provide its indexes. So if outer set does not provide indexes, we can't access the inner set, right? So set concept does not provide any type of indexes. So how can we access this inner set or this outer set? We can't, right? So that is the reason this set in set is not possible to define. If you try to define this, it throws an error called type error. It can't use a set as a set element. So let's see this error in practical. Now I'm going to open Python command prompt to see here. This is one set and this is another set, right? So this is inner set and this is an outer set, right? And set inside another set is known as set in set, right? So this is not possible. Let's see. See here, it throws an error called type error. Can't use set as set elements. Unhashable type, set data type. So set data type is unhashable type. So in order to access this inner set, outer set must and should provide indices or indexes. Set concept does not provide indices. Why in the sense? Because set does not maintain insertion order, right? So that is the reason it does not provide any indexes, right? So if set is not providing index, we can't access this inner set. So that is the reason it is not possible in Python programming in order to declare set in set. So this is about the case one, list in set. This is our second case. Case 2 is list in set, right? So let's see. So the outer is a set only, right? So same thing. It is also not possible to define one list in another set because list is mutable, and to update list elements or in order to access the list elements we need index of set. So it is not supporting and gives a type error. Can't use list as set element. So see here, the same reason comes here. Even though list is mutable, in order to access the list element or in order to update the list element, we want set to provide an index or indices. So set has not ability to provide an indexes, right? So that is a reason this list in set is also not going to be possible. Inner set place, I'm going to declare here list. See here, list which has present in set. So this is list in set. So if I want to declare this, see, it throws an type error. See, can't use list as set element. Unhashable type list. Same reason. In order to access this inner list, we want set to be provided indexes. So in order to access this inner list, the outer set must and should provide indices or index. Set does not provide index, so we can't define this type of list in set. So this is about list in set. Tuple in set. So see here, tuple is an immutable. Set is comes under immutable. So tuple in set is going to be possible here. So set in set is not going to be possible. List in set is not going to be possible. But tuple in set is going to be possible. How we will see right now. So the case 3 is tuple in set. So it is possible to define one tuple in another set because tuple elements are immutable. Immutable in the sense it is not going to be update an element in same memory space. In the sense, if we are trying to update an element in tuple, it is not going to be updated. Even though if it's updated, then the updated value is going to be placed in another object or in another variable. So tuple is an immutable and set is also an immutable. So this tuple in set is going to be possible to define. Let's see the practical. So inside I'm declaring here tuple. See here. So this is a notation of tuple, right? If you observe, this is the tuple. Tuple inside set, right? So then it is known as tuple in set. So if we try to declare this, see, it does not throws any type of error, right? Now I want to declare simple for loop in order to know which value comes under which data type. So for value in our variable called S1, now I'm going to print here like this. See, val, comma, type of that value. In the sense, type of val, type of S1. See here, set does not maintains insertion order, right? So it does not displays output as per our order. It will displays output randomly, right? So that is the reason first it has displayed a tuple. See here, this is an tuple, right? So this is a tuple value which comes under class tuple. This tuple has present in set, right? So this is important. Tuple in set comes here, right? So 20 is an element which comes under class int. and this class int, in the sense this value has present in class set, right? If I want to insert an element into set, I can do that. So our set object is s1, right? So s1 dot add of function in order to add an element into set, right? We have already discussed this in predefined functions of set data type, right? Now see here s1 dot add of 25. If I do like this, the 25 is an element which is going to be add in s1. So let's see. So it does not throw any type of errors. Now I'm going to access s1. See here, this is my s1. So here, this is our tuple, and where is the value 25? Here we got an value called 25. In the sense, we can add an element to the set. So if I try to add an element to this tuple, we can't do that. Why? In the sense, so in order to add an element into this inner tuple, so we want index of this tuple, right? So that index does not provide by the set. So that is the reason we can't add an element into tuple. So we can also remove an element from the set. See here, what is the element I added? In the sense, previously I added 25. I want to remove that added element 25. See here, the 25 has been removed. Now I'm trying to access S1. See, previously we have 25 here, there is no 25. So we can apply all predefined functions, all 17 predefined functions in this set, but we can't do anything on this inner tuple. And one more thing is, I can remove the entire tuple. How? In the sense, in the place of remove of 25, I want to declare this entire tuple. So if I declare this entire tuple, then it is going to be removed like this. See here. So in the place of 25, I have declared this entire tuple. Let's see what it happens. So I'm trying to access S1 here. So in S1, there is no tuple. The tuple has been removed, right? So we can remove this tuple by using this set. Yeah, we can do this also. S1 dot pop off. S1 dot pop off will remove an arbitrary element. In the sense, random element is going to be removed and returned. See here, 20 has been removed from S1 and it has been returned also. If I try to access S1, there is no 20. So previously we have 20 in S1, but here there is no 20. Why? In the sense, I have used this statement S1 dot clear of. If I do this clear of function, the all elements in S1 is going to be removed. See here, if I try to access S1, S1 is an empty set. See, empty set, right? So we can delete this empty set also. See here, if I want to delete this empty set, I going to use simply del of S1. See here, totally empty set is going to be removed. The name of S1 is also going to be removed. If I try to access S1, it throws an error called name error. See here, name error. Name S1 is not defined. It is saying, right? So by using this del operator, we can remove the memory space of the. So this is all about tuple in set. So in this episode, we have completed this combinations with respective set, that are set in set, list in set, and tuple in set. So in upcoming episodes, we are going to discuss about set in list and set in tuple combinations. So that's all for today's video. Don't forget to like, share, and subscribe to Aman Codes. Thank you so much for watching.